Hello everybody, this video clip is still on chapter 6, but it is about the section 6.6, okay? And this section we are going to talk about the so-called implicit derivative, okay? Previously, for the single variable function, if your y is a function of x, which is defined implicitly by this kind of relation, then you know how to find a derivative of y with respect to x by looking at this one as a function of x, right? And then using the chain rule, apply the chain rule to this one, and then you can find out what is the derivative of y with respect to x. Very easy from this kind of relation. Now we are elevate ourselves by look at z. Okay, this z is a function of two variables at least, okay, x and y, and it is also defined implicitly by some kind of relation. Okay, it doesn't mean that it has to be in this relation. Okay, this is just example. Then how are we going to find the dz by dx as well as the partial derivative of z with respect to y? Okay, so of course we are going to use the chain rule as well. Okay, however, in terms of introduction, let us look at a function capital F of x, y, z, okay, of three variables first, equals to constant c. Okay, this kind of equation or relation is said to express your z implicitly as a function of x and y. Okay, so this means that actually your z, it is a function of x and y hidden. Okay, so if you just pretend, okay, this is just pretending, look at the c as a function first, and then this c, because on the left hand side it is a capital F, which is depends on a three variable x, y, and z, right? But then just keep in mind that your z actually depends on x and y again. So actually your c, just pretend that as a function, okay, but actually this c is a constant at the first place. Okay, this c actually will depends on only x and y alone, right? You can just skip the z. So if you want, then you can use the chain rule to find dc, a derivative of c with respect to x. So it will go through this contribution, and it will go through this contribution, right, through the x, I mean immediately, or and through the z. Okay, so it is the dc by dx, and then dc by dz, and dz by dx. Are we good? Okay, this one we don't need to multiply anything because your x is already terminate there. Okay, so just dc dx, that will reach the x immediately. However, what are we going to find? Okay, what are we going to find after you have this kind of implicit definition? You actually need to find the dz by dx and dz by dy. So this is what you need. So you are going to, you know, move some others to the other side. Okay, however, let us because at the beginning we say that we pretend that this c is a function, but actually this c can be is actually on your left hand side is a capital F, right? So let us rewrite a little bit. Instead of using the c here, we use the f here, we use the f here, but we keep this one as a c. Okay, because you know that the derivative of really a constant, it simply what? 0. So you have a 0 on the left hand side, and then you got df by dx. Okay, because your capital F contain a variable x, so you can find this one, and then df by dz, because again your capital F contain a variable z, you can find this one, and this one dz by dx is the one that you really need. So it means that if you want dz by dx, it's very simple. It is just a negative of df by dx over df by dz. Okay, so the thing that you may miss is this negative sign. Okay, it's this negative sign, so you will be very careful when you use this formula. However, as we continue, okay, as we continue doing the example, we are not going to use this formula at all. We are going to just apply the chain rule at once, okay. But this one, I mean, we just introduce you to know that, okay, we have a formula and you have an alternative way to do dz by dx by using a formula as well. But don't forget this negative sign. So on the other hand, if you would like to find dz by dy, then you start with dc dy, which is df by dy, okay. You are going to go through this one and this one, okay, and it terminate here, and df by dz go through this step first, and then dz by dy, this is what you need. So it means that your dz by dy, because this one is a constant, so it simply goes to 0. It is negative df by dy over df by dz, okay. Okay, so this will be a formula for, I mean, if you want to remember, then you can remember, but don't forget again this negative sign, okay. I mean, this one is the summarize of the formula that we have. However, as we did it, okay, we are going to do it using the chain rule, okay. I'm not going to use the formula for you. If you want to use the formula, you do it by yourself, okay. For example, let's look at this one. We're going to look at this one as the z of x, y, and then square, okay, as a function of a two variable x and y, then square. But we don't really know what is the formula for z, okay. If we want to find dz by dx, what we are going to do is to take the d by dx both sides, okay. We just simply take the d by dx both sides. So this one, we got x and z square, x plus y, and d by dx of y square equals to d by dx of 0, okay. So I mean, this is very easy because your y is a constant in this context, okay. Don't forget that your z is a function of x and y, so your x and y, they are independent, okay. So this one is a 0 because your y right now is a constant. This one, of course, is a constant. A derivative of a constant go directly to 0. How about this one? You need to look at it this way, that here is a function of x, there is also a function of x. So what you really need to do is to use the product rule, right? You need to use a product rule. So here what you have is the first derivative of the second, right here, the second, okay. But the derivative of the second using the chain rule, you have 2z and then dz by dx, okay, because right now you have a derivative with respect to x. We good, okay. So it's look like the same thing as you find previously, a derivative of y square, you have 2y and then y prime, okay. This is the same thing, okay, but this one, instead of y prime, we use dz by dx, okay. Then this is the first derivative of the second, right, and then the second, which is z square, and then derivative of the first, which is what, a quotient rule, right. This one is already 0 and 0, so we just stop it here, okay. So here is the contribution from the first term, okay, the first derivative of the second derivative of the first. So you continue further to calculate this one, okay. We just copy this one because it is already done, to z dz by dx, okay. And don't forget that this is the one that you need, okay. But the second term, you need to use the quotient rule, right. So it is the bottom derivative of the top with respect to x minus the top derivative of the bottom with respect to x over your bottom square, and then make it equals to a 0. Okay, so if you need to solve for this one in general, okay, in general, then you know that your dz by dx, it is simply move it to the right hand side. Okay, so we have x minus x plus y over x plus y square and multiply by z square. Okay, and then you are going to do a cross multiply by this one, right? So this x plus y will do a crossing multiply here, and then this one your 2 xz will be cross it down here. Okay, and then if you want you can simplify, or if you don't want you can just leave it like that, it doesn't really matter. Okay, so this is dz by dx in general. However, okay, however, if instead of finding dz with dz by dx in general, but we want to find it, okay, at a fixed number, x equals to -1, y equals to 2, z equals to 2, we encourage you to do it from this one first. Okay, so you plug in x is -1, y is 2, z is 2. Okay, you are going to end up with -1 over -1 and 2. You see x and y, and then a 2 and a 2 z, but don't forget that this one is the one that you need, and then add the 2 square. Okay, and then right here we have -1 and 2, and then minus -1 over -1 and 2, and then a square, make it equals to 0. Okay, so if you want to solve for this one, then you can just calculate, I mean, it as a number, right? So you have -4, you see, dz by dx plus this is 1 and 1, so you have 8, right, over 1 square equals to 0. So it means that your dz by dx is just simply -8 over -4, which is 2. Okay, so this is your derivative of z with respect to x at this particular point. Okay, at this particular point. What if we need to find the derivative of z with respect to y instead? So let us look at this example one more time, but on the other aspect. Okay, we're going to find this one. So first thing you do, you take d by dy both sides again. Okay, so you got d by dy of x z square x plus y, d by dy of y square equals to d by dy of 0. Okay, so again this one is pretty easy, but this one is not 0 right now. This is what, 2y, right? How about this one? You need to look at it this way, that here is a function of y hidden. Okay, because don't forget that your z has y hidden over another function of y right there. So you need to use a quotient rule as well. And the x can be pulled outside because your x is just simply a constant on this context. So the quotient rule says that it is the bottom derivative of the top, which is 2z, and then dz by dy. Okay, this is the same thing as I told you previously, that if you need to find the derivative of y square, it is 2y and then y prime, but then instead of y prime at this moment we use dz by dy. Are we good? Okay, this one, and then minus, this is the bottom derivative of the top minus the top derivative of the bottom with respect to y over your bottom square. Okay, and don't forget this term, the 2y equals to 0. Again, if you want to have this one in general, okay, you can just simply move the others to the right hand side. Okay, so it means that your dz by dy it is this one to the right hand side, negative 2y. This one as well to the right hand side will have the z square over x plus y square. And then, oh, of course, you have the x as well. You have the x on the top as well. And then you are going to cross multiply, right, to get rid of this one. So you are going to cross multiply by x plus y square over the cross multiply but on the bottom of 2z and x plus y. We get. However, usually we are not going to ask this kind of thing, okay? Usually we're not going to ask this kind of thing, but we are going to ask the derivative at a particular fixed point. So here, if your x is -1, your y is 2, your z is 2, you just plug it in there. That will be a lot easier. Okay, so you have your x to be -1 and 2, and 2, and your z is also 2, dz by dy, that is the one you need, and then you have 2 square over -1 plus 2 square, and plus the 2 and the 2, make it equals to 0. So to solve for this, you just calculate it first. So you have 4 -4 dz by dy over 1, right, minus so it will be a plus 4, and then another 4 equals to 0. So your dz by dy at this particular point, x is -1, y is 2, z is 2, it is equals to -8 over -4, which is again a 2. Okay, they happen to be the same. Okay, they happen to be the same. Well, right, so this one you just apply the chain rule at once. Okay, we didn't use the formula that's given here. So if you want, okay, you can use this formula by yourself at home to solve for this problem again. Okay, so let's look at the second problem. Okay, the second problem involves the exponential and the logarithm. Okay, but it's not that difficult. Okay, it's really not that difficult. Again, your z is a function of x and y, but now defined implicitly like this. Okay, so to find a dz by dx, you are going to take your d by dx both sides. Okay, so we have d by dx of the first term, and then equals to d by dx of the second term. Okay, and we simply use the chain rule. Okay, so the derivative of e to the something is just e to that one, but then a derivative of the exponent with respect to x, so you got dz by dx. Okay, because we don't know what the z is. This one, a negative, can be pulled out, right? And then even though here is the y, but don't forget that this one you have your x hidden in your z. So this one you have 1 over y plus z, and then a derivative of the one behind a logarithm with respect to x, it is 0, and also dz by dx. Okay, so now you got this one as 2 terms, so you are going to combine, okay, each one of them together. So you got dz by dx. On this side you have e to the x plus z. On this side you got a negative, so it is a positive of y plus z. Okay, and then make it equal to this one, you just move it the other way, so you have negative e to the x plus z. So it means that your dz by dx, it is negative e to the x plus z over e to the x plus z plus 1 over y plus z. Okay, and you don't really need to do any, you know, simplification or anything. You can just leave your answer like this. That will be good enough to be your final answer. Okay, what if you need to find a derivative with respect to y? So you are going to do it the same thing. you take d by dy both sides. Okay, so you got d by dy of e to the x plus z equals to d by dy of negative log of y plus z. So this one, a derivative of the exponential, it is the exponential itself, and then a derivative of the exponent with respect to y. Don't forget here you got y hidden, but x has no y, and this one dz by dy, because it is hidden but you don't really know what it is. This is negative 1 over y plus z, and then a derivative of the inside the logarithm, you got 1 plus dz by dy. Okay, you got 1 because here is a derivative of y with respect to y. Okay, so to calculate this one, you just pull the thing together. So here is already there, and then this one you have the add, right, the addition of 1 over y plus z, and then this one is already on this side, which is negative 1 over y plus z. So it means that dz by dy, it is simply negative 1 over y plus z over e to the x plus z plus 1 over y plus z. And don't bother simplify anything. Leave it like that. That will be your good final answer. We get? Okay. So let's look at this function further. Your t, right now your t is hidden. What? This one have your s, your r, and your u hidden inside the t. So if you want to find the t du, then what is it that you do? You take d by du both sides. Okay, so you have d by du of s e to the r square u square, d by du of u log of t square plus 1. So don't forget that all these, they are independent. So right now if you concentrate on u, it means that your r and your s, they are constant. Okay, they are constant. So this s can be pulled out, and then a derivative go directly to the e. So you have e raised to power r square and u square, and then a derivative of the exponent with respect to u. Don't forget your r has no u and is independent, so it is a constant 0. So this one, the derivative of u square, you got 2u. Okay, but this one, your t got r as u hidden, and you have a u multiplied. So it means that on the right hand side you really need the what? The product rule. So it is the first derivative of the second. Okay, so derivative of the log is 1 over, and then derivative of the one inside. Okay, we have 2t, but your t is also a function of u, so it is 2t dt du, and then this is the first derivative of the second, right? So you have another term, the second derivative of the first with respect to u. Okay, so here is what you need, right? So it means that dt du, it is simply this one, 2u as e to the r square u square, and then minus log of t square plus 1, because you have the plus here, so you move it over there, and you are going to you are going to do the divided by 2tu over t square plus 1. You see 2tu, and then the t square plus 1 that is multiplied with this. So you just divide the right hand side by this whole thing, or you can just flip it up. Okay, it doesn't matter. So this one can be your good enough to be your final answer as well. Okay, so we encourage you to find dt by dr, and of course dt by ds by yourself at home. Okay, Now if we have the word problem, okay, if we have the word problem like this, it says that the joint cost function, of course this one is the C, right? Okay, and this C depends on the QA and the QB, but instead of having explicit C equal, you got C plus a square root of C equals to 12 plus QA, and then a square root of 9 plus QB square. Okay, so what if your QA is 6, your QB is 4? Can you find the cost C? So let's try the first question. So you are going to plug in, okay, you are going to plug in your QA to be 6, your QB to be 4, so it is a 4 square, so it is a what, 12, and this one is 16 plus 9, so it is 25, so it is 5, okay, after the square root then multiply by 6, so you got 30. So you have the equation of C plus a square root of C minus 42 equals to 0. Okay, so can you see it as a quadratic equation? Okay, this one is a square of a square root, right? So you can do a factorization depends on a square root. Okay, and 42 you can think of 7 and 6, right? But then you need positive, then then your 7 must be positive. But because your C, I mean the square root of C is positive, and you add more by 7, so it cannot be equals to 0, right? This term, so this term is gone, but the one that survives is the square root of C minus 6 equals to 0. So it means that square root of C is 6 and your C is 36. Okay, be careful because you need to have the corresponding value C. So right now your C is 36. How about if you want to determine a marginal cost, okay, with respect to both of them? So you are going to find like one by one. So let's find a marginal cost with respect to the QA first. Okay, so you are going to again take your derivative with respect to the QA both sides. Okay, because you have your QA hidden in the C, so you have the d by dc by dqa, and the derivative of a square root of C with respect to QA equals to a derivative with respect to QA of 12 and QA and 9 plus QB raised to power 1/2. Okay, so this one, because I mean the C has, I mean we don't know what it is for C, so we need to leave it like this. Okay, this is sometimes make student confused as well, because this C has the QA and QB, Q sub A and Q sub B hidden, but we don't know what is the formula for C, so we need to leave it as a symbol like this. However, if you're talking about a square root of C, you can further simplify by taking the chain rule. So it is a C raised to power 1/2, so you have 1/2 there, and C raised to power negative 1/2, and the chain rule, you end up with the derivative of C with respect to QA. This one, a derivative of 12 is 0. This one, only this term is a variable, but the 9 and the QB, they are constant. Okay, and the derivative of QA is simply 1. So you have this, but you need this quantity, right? Because these two things is a marginal cost with respect to QA, and you need it when your QA is 6, QB is 4, and we just know that if your QB is 6, your QA is 6, QB is 4, then the cost is 36. So you are going to plug in what? QA to be 6, QB to be 4, and C to be 36 as we calculate. Okay, so you are going to end up with DC DQA, and then half of 1 over square root of 36, and then another DC DQA equals to 0, of course, right? And then I forget a square, sorry. Okay, so you have 9 plus 16, okay, because it is 4 square raised to the power 1/2. Okay, so this one, what is it? This is 1 over 12, right? Because it is 1 over 2 and 1 over 6, so it's 1 over 12. So add that together with that one, and also this one, it is what? 5. Okay, so it means that your marginal cost with respect to QA, it is 5 multiplied by 12 over 13, because this one, it is a 1, right? 1 plus 1 over 12, it is 13 over 12. So you have this one, okay, which is 60 over 13. Okay, so can you still interpret? Okay, can you still give the interpretation? Okay, so this one, we encourage you to write down the interpretation by yourself. What is this number 60 over 13? What does this mean? Of course, it means that the cost function is going up, right? The cost function is going up. Okay, but what is the other factor? Okay, which one increasing? I mean, by what, and which one is fixed by what? Okay, we get. So this is a marginal cost with respect to QA. What if we need the other way around, a marginal cost with respect to QB? So don't forget that this one we already calculated, it is 36. Okay, so you are going to take D by DQB both sides, right? Okay, so again, the first one, because you don't know what the C is, so you need to leave it as a symbol like this. But for the second one, you can simplify it further by using the chain rule. Okay, so it is 1/2, and then C raised to the power negative 1/2, and the DC by DQB. Okay, on this one, the right hand side is 0, of course. The QA is a constant, and then this one is a 1/2, right? Raised to the power 1/2, and a 9 plus your QB raised to the power negative 1/2, and then the derivative of the inside, which is 2 QB. Okay, and you replace your QA and QB and your C by these numbers. Okay, so you do the plug in again. So after plug in, this is DC by DQB, and then this one again, it is 1 over 2 and 1 over square root of 36 DC by DQB equals to the QA is 6, and then over 2, and then 9 plus 4 square raised to the power negative 1/2, and 2 QB is 4. Okay, so again, on this right hand side, left hand side, you have 13 over 12 DC by DQA. How about this one? This is simply a 3. This is 1 over 5, and then this is 8. So it means that DC by DQA at this particular point, okay, you have 24 over 5, and then do a cross multiply by 12 over 13. Okay, 24 over this. Okay, and then, I mean, if you need, you can use your calculator to have this one as 288, and this one 13 multiplied by 5, it is 65. And we also encourage you to give the interpretation of this number. What is it? Okay, of course again, oh sorry, this is a B. The price, okay, the cost function is going up again, okay, but under what circumstance that is going up by this many dollars per unit. Okay, so we are going to stop this clip right here, and we'll see you then after that. Bye bye.